What do graphs of motion look like? This is the question that students will explore in Investigation 1A, Graphs of Motion. The primary goal of Investigation 1A is to introduce your students to data collection and graphing using the SmartCart and SPARKvue software. This introduction is important as the SmartCart and SPARKvue software will be used repeatedly in investigations in later chapters. For this investigation, students should be familiar with identifying trends in XY graphs, but they do not need to start with an understanding of motion. In particular, they do not need a formal understanding of position, velocity, or acceleration. Part 1 of the investigation focuses on collecting real-time data that represents the motion of the cart. Students begin by opening the SPARKvue experiment file indicated in their student handout. This file is titled 1A, Graphs of Motion. Students will find this experiment file in the SPARKvue application by clicking the Open Pasco Experiment button on the welcome screen and then selecting Essential Physics. This list of experiment files contains all of the SPARKvue experiment files used in any of the Essential Physics investigations. In the future, if an investigation indicates that a SPARKvue experiment file is used, it can be found in this list. Each SPARKvue experiment file is unique to its investigation. All of the displays and other data collection and visualization settings have been pre-configured for your students. Students simply open the file, connect their sensors, and then follow the instructions in their handout to record data. The data from the sensors will automatically populate the existing graphs and tables unless otherwise specified. For Investigation 1A, after the experiment file has opened, students then connect their SmartCart using Bluetooth. Once the cart is connected, groups record data by clicking the green Start button at the bottom of the screen. To stop recording, click the red Stop button. For Part 1, groups will record data while rolling the SmartCart back and forth on their table. Students should avoid recording really long runs of data and try to record multiple shorter data runs instead. If students wish to see multiple runs of data, runs can be hidden or shown by clicking the check mark in the legend. Have students read the Part 1 questions and then record data that helps answer them. Student responses to questions A through C in Part 1 should show a general understanding of the trends in the graph. To answer question D, students can zoom in on their position time data to find the smallest change between two data points. Or, students can use the coordinates tool to scan through the data points, finding the smallest change in the y-coordinate values. Before recording data in Part 2, students should go to the second page of the SPARKvue experiment file and then hide all the data so the graph is blank. In this part, students attempt to move the cart and record position time data in a way that matches the two graphs in their handout. This is the first graph, and this is the second graph that they'll be matching. The motion that matches these graphs is similar to the following. Just like that. Students must then describe the cart's motion that produced the data in each of those graphs. This is a description for the first graph, and this is the description for the second graph. For part 2, it's helpful for student groups to have one person who moves the cart while observing the data, and a second person who's paying attention to the actual motion of the cart so they can describe it while data is being recorded. In part 3, students record force data using the cart's hook and bumper accessories, which both screw into the front of the cart like so. Before recording data in part 3, students should go to the third page of the SPARKvue experiment file and again hide all the data so the graph is blank. Students loop the rubber band around the cart's hook and then record data while pulling on the rubber band, both while the cart is stationary and rolling. Students will use their new force data to answer the part 3 questions. For questions A and C, students will need to look back at the velocity time graph on page 1 of the experiment file to determine whether the cart's motion is in the positive or negative direction. Positive velocity is motion in the positive direction. Negative velocity is motion in the negative direction. For question B, attach the rubber bumper to the smart cart. Then, rest the smart cart against a book. Now, record data while pushing the rubber bumper into the book. For questions A and B, students should identify that pull force is positive and a push force is negative. If the cart moves in the same direction as the force, the direction of motion matches the sign of the force. For question C, students will find that it is possible for the force and direction of motion to have opposite signs. For example, pushing on the cart's bumper while rolling it forward, or pulling on the rubber band while rolling the cart backward.